Hello everyone, my name is Bhaskar Goyal and I am a software engineer at Google. Today I'll be presenting a talk on building bulletproof AI systems from container chaos to production paradise. The journey is often described as a nightmare, a chaotic world of containers, configurations, and last minute fires. We are here to change that narrative. In this session, we will explore how to transform that deployment narrative into a production paradise. We will look at battle tested architectural patterns that will help you build bulletproof AI platforms that actually deliver on their promises. Let's start by acknowledging the reality of enterprise AI deployment. Many organizations, despite their best effort, run into significant hurdles that lead to delays and even project failures. These challenges generally fall into three categories. The first is environment inconsistencies. We have all heard it but it works on my machine. This syndrome leads to the unpredictable behavior when models move from a data scientist laptop to a staging or a production environment. Inconsistent libraries, dependencies, and even hardware can cause the models to behave different or fail entirely. The next are the manual deployment processes. These are often error prone, incredibly time consuming, and create bottlenecks. They frequently rely on specialized knowledge of a few key individuals. If that person is on vacation, good luck deploying that critical update. And finally, this leads to the production fires. Those late night emergencies caused by unforeseen discrepancies between what was tested and what is now live. These fires not only burn out our teams but also erode confidence in the AI initiatives themselves. The result is a deployment cycle that stretches from days into weeks or even months, drastically diminishing the returns of our AI system. So, what does the production paradise look like? Leading organizations have already transformed their AI deployment processes, and the results are dramatic. Success isn't just about avoiding failure, it's about creating a streamlined, efficient, and reliable system. Imagine reducing your model deployment time from weeks to mere hours. Think about cutting configuration drifts and errors by as much as 80%. This is achievable. We are talking about true deployment to production parity, which eliminates those nasty late night surprises. Furthermore, success means having scalable infrastructure that grows with demand without breaking your budget. It means empowering your data scientists with a self-service platforms, allowing them to innovate faster, all while maintaining the governance and control the business needs. This is the paradise we are aiming for. Okay, now let's look at what the session mode map will look like. How did we get here? I have structured our journey today into four key parts. This is your part platform success. First, we will dive into containerization strategies, specifically how Docker and Kubernetes can eliminate environment inconsistencies. Next, we will cover infrastructure as code patterns using Terraform and Helm to prevent my configuration drifts. Then, we will explore GitOps workflows to automate our pipelines and make them versioned and trustworthy. Finally, we will look at real world ROI data from organizations that have successfully implemented these patterns at scale. Our foundation begins with containerization. This is what solves the classic "it works on my machine" problem by unpacking and packaging our models, all their dependencies, libraries, and runtime configurations into a single portable unit. But AI workloads have unique needs that generic containerization approaches often don't address. We need to think about GPU acceleration and access to other specialized hardware. We are often dealing with very large model artifacts that can be gigabytes in size, which has implications for image storage and memory requirements. And our inference and scaling patterns are often very difficult from traditional web services. The impact of getting this right is huge. As a principal ML engineer at Forbes 500 financial services company put it, containerization reduces our model deployment failure by 65% and eliminates an entire class of environment related bugs. This is the power of a solid container foundation. To build on that foundation, we need to use Docker patterns that are optimized for AI. Let's look at three key ones. First, Multi-stage builds. This involves using separate development and production stages in our Docker file. This results in a much smaller, more secure final image, leading to faster pulls, a reduced attack surface, and lower resource consumption. Second, the hardware-aware base images. Don't use a generic base image for everything. Use CUDA-enabled base images, especially for your GPU workloads, to get maximum performance. For CPU-based inference services, use CPU-optimized images. This simple step can drastically improve performance and minimize cost. And the third, a smart layer caching strategy. Structure your doc files to maximize build cache hits. This means placing stable dependencies like system packages at the beginning of the file and frequently changing code like your model artifacts towards the end. Together, these patterns significantly reduce image size and build times, accelerating the entire development cycle. Once we have our optimized containers, we need a way to manage them at scale. This is where Kubernetes comes in. Kubernetes provides an orchestration layer that makes our containerized AI deployments truly production ready. Kubernetes gives us powerful capabilities like horizontal pod autoscaling. This allows us to automatically scale our inference services based on CPU, memory, or even custom metrics like the number of prediction requests per second. This ensures we have the capacity to meet demand without over provisioning resources. For our expensive hardware, we can use GPU node pools and resource quotas. This allows us to efficiently and fairly allocate these costly GPU resources across multiple teams and workloads, ensuring maximum utilization. Finally, Kubernetes enables advanced deployment strategies like canary deployments. We can gradually roll out our new model versions to a small subset of users, monitor their performance, and then proceed with a full rollout, significantly reducing the risk of a bad deployment. Now let's move to our next pillar, infrastructure as a code, or IAC. IAC transform your AI platform from a fragile, manually configured snowflake system into a reproducible, version controlled, and automated one. The key benefit is environment parity. With IAC, you can create identical deployments, development, testing, and production environments with a click of a button, eliminating the it works in dev surprises. IAC is also your key to robust disaster recovery. If an outage occurs, you can rebuild the entire platform, reducing downtime from days to hours. It also ensures consistent compliance and governance by allowing you to implement security controls and access patterns as code applied uniformly across all deployments. Terraform patterns for AI infrastructure is very important. When implementing IAC for AI, Terraform is a fantastic tool. Let's look at three battle-tested Terraform patterns. First, a module-based architecture. Instead of writing monolithic configurations, define reusable infrastructure modules for common AI components like model registries, inference clusters, or feature stores. This promotes consistency, accelerates development, and simplifies maintenance. Second, a clear environment promotion strategy. Use separate directories or Terraform workspaces to manage your different environments. This ensures that identical configurations are applied consistently as you promote changes through your CI/CD pipelines, minimizing discrepancies. And critically, use remote state management. Use your Terraform state files in a remote shared location like an S3 bucket or Google storage with locking enabled. This is crucial for team collaboration, prevents corruption, and maintain an authoritative record of your infrastructure configuration. Always ensure encryption and versioning are enabled for security and auditability. This brings us to GitOps, which ties everything together. GitOps transform our manual deployment processes into fully automated, auditable workflows by making Git the central hub of our operations. The key components are simple but powerful. Git becomes a single source of truth for both infrastructure and applications configurations. We use pull-based deployment operators like Argo CD or Flux that automatically sync the cluster state with what's defined in Git. And we have continuous verification that detects and remedies any drifts from the desired state. The enterprise benefits are immense. We see an 80% reduction in deployment time and a complete audit trail for compliance, self-healing architecture that maintains its desired state, and simplified rollbacks. Just you just revert a git commit. Simple. So what does this all mean for your business? The return on investment is tangible and significant. Organizations adopting these patterns have seen an 85% reduction in deployment time for complex AI workloads, moving from weeks to hours. They have experienced 73% fewer production incidents due to environment consistency and automated testing. We have achieved 40% infrastructure cost saving through better resource utilization and auto scaling. And perhaps most importantly, they have been able to get 3 times more models into production, dramatically increasing the throughput and impact of AI delivery pipelines. I wanted to leave with a clear, actionable plan to get started on this journey. Here's a 30-day plan for some quick wins. Start with by containerizing one high-value AI workload using multi-stage Docker builds. Establish basic Terraform modules for your key infrastructure components and set up GitOps repository to manage configurations and automate your initial deployments. From there, you can accelerate towards production readiness with a 90-day transformation plan. Implement Kubernetes clusters with GPU support, introduce canary deployment strategies for safer model updates, and set up comprehensive monitoring and observability solutions tailored for your AI workloads to ensure ongoing performance and reliability. By embracing these principles of containerization, infrastructure as code, and GitOps, you are truly moved from container chaos to a production paradise. You can build AI platforms that are not just powerful, but also reliable, scalable, and bulletproof. Thank you so much for your time, and we're happy to answer any questions you have. Thank you for this.